me and my team at Google, we have been working on this SQL engine called Tenzing. I think I finally have this. There you go, technology works. And so I woke up about 5 hours before my usual time today, so I might be a bit woozy. Excuse my random thoughts. So my name is Biswapesh. I'm from Google, and my colleague Viren is sitting right there, videotaping the presentation with me. And me and my team, we worked for about 2 years. That's about 10% years on this tool called Tenzing, which is a SQL engine on MapReduce, yet another. There are some key differences, and this talk is mainly about that. It's kind of difficult to compress 10% years of effort into 20 minutes, but I'll try my best. And these are the email addresses of my colleagues who work with me. We do have good spam filters, by the way. Okay, about Tenzing. So let's talk about why it is different fundamentally. So basically it's quite simple. It's a SQL engine on top of MapReduce framework. We have heard about Hadoop SQL, we've heard about Hive, and a bunch of other stuff. There are many other distributed engines available. Microsoft has tried Scope, I believe. Also, there are a lot of commercial ones like Glean, Plum, Natisa, Astradata, and so on. So what makes our engine different? So I think the first point is that we have a very, very efficient engine by, if you compare to like some of the other open source or the distributed processing engines available on the MapReduce. We are fairly low latency, high throughput, high scalability, and high resilience, all of which come from the fact that we are based on the Google implementation of the MapReduce framework. Tenzing is written in C++, by the way, on top of the core MapReduce framework. We have very, very good SQL support. So we have, I have a separate slide on that, but we do have fairly extensive SQL analytical support with a lot of interesting extensions. Hopefully we'll get some time to talk about that. We are heterogeneous. This is fairly common with the MapReduce framework, but not so much with databases. What I mean by heterogeneous is we can connect to all sorts of different data sources directly and do efficient executions on that. So as things stand now, we can connect to protocol buffered databases on GFS, to big tables, to columnar storages, to sharded MySQL databases, which some of our systems still use, and so on and so forth. We have a fairly extensive support for all the different formats that are currently used under Google. The main advantage of that being that we don't need to load the data into the database. You can pretty much start querying the data right away. Optimizer, obviously it's a relatively young effort. We do not really have a very advanced optimizer, but we do a fair amount of optimizations, both rules and cost-based, based on various heuristics on the data. And one of the interesting things about our optimizer is the optimizer is heterogeneous aware, which means that, for example, if you are querying a flat data, we will do the filter by pulling the data into our system. But if you are querying a big table which supports indexes, then we can push the indexes into smaller scans on big tables. Or if you are querying a MySQL database, we can actually convert some of the where clauses into MySQL where clauses and push it directly to the database to get the data, which makes the engine quite efficient because it can utilize the features of the different systems that it is querying at runtime. And finally, we have integrated metadata management. That means that you can create tables, drop, all the standard DDL, DML stuff you're used to in the normal database, in bulk inserts, load, unload, and permission systems, all kinds of metadata stuff that goes with standard traditional RDBMS you can actually do on top of the Tenzing framework. Finally, the numbers. We have about 1,000 plus user base. 80% of them are non-engineers. Engineers typically prefer not to use SQL for a lot of their work, so our engineering base is relatively weak, but we do have a fairly significant non-engineering community pool who use Tenzing extensively. About 20K queries per day. A lot of them are heavy pipeline type queries. We're doing a lot of joins, aggregates, and things like that. Lots of data. This is fairly common at Google, I guess. We do have multiple databases with multi-petabytes of data. The core Tenzing service, I believe, is approaching, I don't know, definitely order of 2+ petabytes. We do have another system at YouTube who is using Tenzing on 1 petabyte plus data. By the way, if you have any question at any point, please feel free to stop me and ask.
So I have a quick one, I guess. About how much data is touched per query on average?
That's a good question. So it depends entirely on what kind of data it is. For example, if you are touching columnar data, so even though you might be doing a full table scan on a 1 trillion row table, but you'll be touching maybe only 2% of the data because it's like a count star on a certain column and you only end up scanning that column. So it depends, really depends on the data. If you're doing a full scan on a big table and one column in the big table contains all the data, then you'll end up scanning the entire big table, which might be like several terabytes. But does that answer your question?
Thank you.
Okay, that's the high-level design. Again, nothing very remarkable from above, I guess. 10,000 foot view, we have standard access mechanisms. You have a web UI where you can write pretty SQL statements. We don't support auto-init. APIs, Python, C++, a command line interface similar to like MySQL or Oracle like SQL plus command line interface where you can write SQL queries and the results will be shown on your screen. You can dump your results to local files, blah, blah, blah. You can create tables in any format on GFS. So you can write a query like, create table, my table, column IO, column some path and select blah, blah, and then it will create a GFS file and it will automatically import that metadata into our metadata repository. So you can start querying that file from Tenzing. And of course, those files are now also available for querying by your raw MapReduce, Sawzall, and other Google tools. As with MapReduce framework, we have different modes of execution. You can use Tenzing like a normal MapReduce. In other words, you kick off a bunch of jobs on our, we call it Borg. It's basically our distributed execution environment, lots of thousands of machines. You can use our service, which is basically a pool of workers and masters which are continuously running on our distributed execution framework. That significantly reduces latency because there is no startup cost associated with processes, so you can get your result of your queries back in a few seconds or a few tens of seconds. Local controller versus query server. Again, if you have full access to your data, you can run the binary locally. We also have a typical client server mode where the query is dispatched to a